All right, I see we have some people filtering in. We're going to give our guests a minute or two to join. So if you hear any silence over the next minute, that's why. All right, welcome. We'll see a few more people. We're just going to give the rest of our guests another minute or so to join the session before we kick things off. All right, looks like we've got full room for now, so we'll get things kicked off. Welcome everybody to today's session. Thank you for joining us, for taking your time with us. If you're not familiar, we hold our Torque Talk sessions every month to give our users a chance to see our latest product functionality in action, as well as ask any questions they want to see anything, see how Torque might work for them. Today's session, as you're well aware, will show how our users leverage generative AI to simplify and accelerate how they build and maintain application environments. Before I introduce our speaker, just a little quick housekeeping. I remind everyone for every session that these are interactive, so please don't be shy. Our Q&A is open. We will spend a few minutes after the demo today to answer your questions live on the call. Our speaker today is Homer Ventura. He's a senior developer with Poly. He can answer any questions that you may have about work. So I think you've heard about enough from me for now. So I'm going to hand this off to Homer to kick off the session.
Okay, so thank you, Colin. So yeah, we are going to talk about today on practical usages for AI, specifically in Torque. So we'll see the usage of AI in several places in our product, starting from setting up an application infrastructure templates based on user inputs. We then go ahead and use AI to find and fix problem with the infrastructure setups that slow developers. And finally, we'll see how we also use it for cost optimization. So before we talk about the solution and improvements using AI, let's talk about the problem. And the problem we see in the field right now is the increasing demand for cloud resources from users and developers, which handled traditionally by the automation expert and infrastructure expert. But the lack of expert compared to the user is a problem. The limited number of experts cannot keep up with the growing needs for real-time infrastructure, which causes significant bottlenecks, resulting in long wait time and also decreased productivity. This is where we stepped in and lately improved upon using the Gen AI. So how did we do it? I don't know how many of you know about Torque launch flow, so very briefly, the main flow in Torque is to identify and import the organization assets. It can be Terraform, CloudFormation, Helm, etc. And then from those assets, create a blueprint, which are YAML files written in Torque language, and then publishing those blueprints to the catalog page so that the user can launch them. And once launched, they appear as an environment for the users to consume, and then, of course, collect and create reports for the admin. So the three places we improved this already existing flow is in the blueprint generation, in the debugging problems in the environment, and lastly, in cost optimization in the reports for those environments. Okay, so let's see a small demonstration, and we will use AI to launch a small, cool image recognition app. And we will do it by first writing down a small TF, the Terraform file, that serves as the reserved EC2 and setting it up with just 5 lines of bash scripts. Okay, let's see it. Okay, so this is the Terraform file with all of its glory. And that's some 5 lines that basically launch image recognition app. But it's of course not enough for a successful launch in AWS, because as you can see in the sketch, the EC2 definition is only part of the infrastructure we would need to create it in AWS. Among other things we will need, if we want to publicly expose it to the user, is a gateway, public subnet with dynamically assigning public addresses, security group with HTTP rules, and finally routing to tie it all up. It's very long and cumbersome process, and I only have the EC2 instance. But we will see later how we can leverage AI to help us with all of that boilerplate. But first thing first, let's import this tiny TF file to Torque, and so we can create a blueprint from it. So what we're going to do, going here, discovering assets, discovering my Terraform file, and creating a blueprint from it, just one click. You can see that the blueprint was created with everything and everything it needs, its input. And so we can finish and I'll go ahead to the blueprints and we can see it. In here. So I can publish it as an asset. And so we can reference it in Torque. So now, but remember all the missing infra that we said we needed for the blueprint to work? Well, one way we could do it is writing all the blueprints to all the other components ourselves, writing all the Terraform files, all the assets, but that's a very time-consuming process. How wonderful would it be if I could just ask someone else to do it for me? So let's do just that. Let's create a blueprint and call it test. And now we are going to use the AI blueprint generation to fill out everything else by entering very simple prompt. So let's go and this one. And I'm saying I recently added an AI image asset and which need to be publicly available to users in AWS. Create me a blueprint and launch it in VPC with everything it needs. So let's generate it. So as you can see, I didn't specify anything. I didn't specify what I want to create, how. I just said with everything it needs. And I'm letting the AI figure it out on its own, making the connection, creating the blueprint, everything else it needed. And as you can see, it did a very, very good job creating the blueprint. With all the connection between the blueprints, everything, the VPC, the subnet, security group, and finally, the thing that I created, the EC2. But all of this, he figured it out on his own with all the dependencies of the connection. You can see in the blueprint even that here is my, my file, my Terraform file. But it's depend on subnets that I would need to create otherwise, with all the inputs. For someone new in Torque, it's very daunting, and the AI can do it in just a matter of seconds. So we can now save it. And we can launch it. Give the inputs, give everything we need, and launch the environment. Okay, to save time, I already launched one before, and you can see in here. We can see it's running, active, all of the components are exactly where they need to be. And I can go ahead and use it. So let's just try it out. Go choose an image and execute. Just like that, with few lines of code and few lines of prompts. So did a very good job. Close up a cat sitting on a window. Maybe I don't see a window, but I can definitely imagine it. A close up cat with its eyes closed. Yep. So we launch a very cool app in a matter of seconds. It would have taken me longer time to write the blueprints, and I'm one that familiar with Torque. So it's very cool that we with just a few lines of code and a simple prompt can do this. So this is just one example where the incorporation of AI capability made a big system and a big flow to look like a walk in the park. And you can also do it and go to the playground, and you can go ahead here and create any blueprint you want. We supply some examples, like for example, something with yes, and very cool apps in it. It's very easy, even if you don't have any assets, because there are some in the community already available for you. You can play with it. And again, if you weren't so familiar with Doc, it would have taken you much longer, but in here, matter of seconds with AI. So let's go and continue the presentation. Okay, so this we saw first flow. And in the previous demo, we saw successful environment launch. But that's not always the case. Sometimes launches will fail, maybe it's our fault, we didn't write the assets correctly, or maybe it's something else. Anyway, those errors might be complex because we are dealing with deploying resource in the cloud. And it can be very difficult if we don't know every little aspect of every resource. Those error in deployments are another great use case where we can harness AI in the day-to-day activity. So that's a quick example to show what I mean. Yeah. Okay. So in here we see a failed environment that had some error in the planning step. Let's see what the error is. Unsupported attribute, the object has no argument in this block for exported attribute name named in bucket call CIM. Okay. Now what? What am I supposed to do? I don't see any suggestions on how to fix it. If I'm not familiar with the bucket, so it will be somehow hard. So right here, you can see the AI insights feature. And let's click it. What it does, it explains in layman terms what the error is and what to do in order to solve it. Give you a very constructive steps and a very simple explanation. So the error message indicator was properly telephone. You're trying to use attribute that does not exist. So identify the problem first. You see line 22, you have this resource, and the attribute name is it doesn't have this attribute name. So understanding what the problem is. The bucket does not have attribute called name. Instead, it has an attribute called bucket, which represents the name of the bucket. So collect the attribute, so correct the attribute, correct the name with bucket, and then go to line 22, replace it, launch again. So we can see we are getting down to earth explanation on what happened and a detailed steps on how to resolve it. So another great example on how we can use AI directly from our code base without the need of leaving the portal in order to quickly fix and save time for the DevOps team to manage failures. So that was the second example. Okay. Now let's go. Now, the third example and the last part of the AI usages is in the cost optimization. In this picture, you can see a representation of an environment lifecycle. And we start, of course, by launching it. And we are doing retries on specific errors in torque if we see them. No AI was involved there. And then after some time, it gets active and we can use it. But after some time it's in the air, there may come a point in which it's not in use. And it's just sitting there idle, presenting here as red. But the problem is we're still paying for it. Like you already guessed, I think, we once again use machine learning to identify those idle times and tell the user in the reports how much money you would have saved by shutting down those environments in those times. Now, a disclaimer. In most cases, it won't completely clear the cost for those environments, only decrease them. Because if, let's say, for example, it was EC2 that we stopped, then there may be other expenses like storage that we still incurred even after we stopped this EC2. And that's why we see the blue rectangle and above it the gray. The gray is what we would have saved if we stopped this VM in those time. But the blue ones, it's the cost that we had to bear, like the storage, even if the EC2 was shut down. So, how we did it? And what enabled us to detect those idle times is a machine learning model that we train that gets as input many matrices like CPU usages, disk read and write, inbound flows, networks in and out, and many others. And produce a response telling us whether this EC2 or VM is active or not. We do this for every VM every hour, meaning we collect the matrices for a given hour and then feed it to the model. It gives us a response of active, yes or no. We did it using training a small model using VM, using a SVM algorithm, which is an algorithm for binary classification problem, like the one we have, meaning determining if the resource is active or not. SVM also known for its ability to handle complex decision boundaries, and it's also working very well with high dimension feature space, like the metrics we pull from the cloud. So given all those features, we trained and the training data, we trained a small model that that can answer very specific question, determine if a VM is in use by inspecting the matrices for a given hour. So again, it's a nutshell how we done, what we did and how we done. And again, we see another example of how machine learning helped us achieve a task that was otherwise be a very complex endeavor. So then after we have this information, we can present it to the user. And you can use those idle times insights and incorporate them to our cost reports, giving the user a big picture on spendings, how much money we could have saved, how much money we did save, along with other cost reports for the organization. So you can see here that this is how much money we saved in torque by using workflow and other mechanism to shut down the VM. And if we did it properly, and we did have some VM that still was active when they shouldn't have. So we presented to the user as opportunity to save and show them in the reports along with the graphs. So again, something to the admin and for the other hierarchs people in the company. to control their spendings done with AI. So we saw three steps or three flows that we incorporate AI directly to the code base, which boosts productivity both for the users and the DevOps team. So those are the three points that I wanted to talk about today, about how we incorporated AI in Torque. I'm done with the presentation. If anyone has questions.
Thank you, Tomer. Yes, we did have some questions come through, and we're still open for questions. So if anyone has any others, please feel free to submit them, and we'll try to make time. We had a question come through early on in the session when you were creating a blueprint using the AI blueprint designer. One of our attendees here asked, where do you get the assets? Where does Torque get the assets when creating the blueprint?
Okay, good question. And the asset can come from different places. It can be assets you have lying around in the organization repository that you imported to Torque as asset, like we did in the first demo. And it can be asset you imported to Torque using Torque community. We have a bunch of assets for AWS, Azure, and Kubernetes. You can go to them using community and then assets, and then you can explore and see assets to create VPC, create EKS, EC2, going to Kubernetes. There are a bunch of applications that you can start from the get-go. You don't have to start fresh, because starting with a blank page is the worst syndrome. And we also have Torque assets in which you can create spaces even using Terraform, meaning asset that in the Terraform you create space on Torque. It's like upside down, you're using Terraform to create spaces in Torque. But we saw customers that it was a great benefit to them in the CI all the time to create spaces on demand, create repository and the entire workflow just in a single button, and then to destroy it. So it's also an assets in Torque.
And I want to take one quick second to plug the Torque Playground. So all of these community assets that you see here are accessible in the Torque Playground if you go to quali.com and navigate to visit the playground. It's essentially a public-facing version of what you see here in Torque, where you can go and start to build, test drive our AI functionality here to build some blueprints using those assets, so you can get started without providing your own repositories yet. You had another question involving blueprints as well. One of our users here asked if you can use Torque blueprints in GitHub.
Yeah, you can have blueprints in GitHub or any other source control you choose, and we will scan for them. Or you can write them down yourself and store them in Torque using the UI designers that we saw earlier in the demo. If we go back, so here are blueprints that I have lying around in my repository. I can start using them directly because Torque will scan them if I will add the repository in here. Or we can go and create blueprints on its own, right? On our own, like example, we can go right here and create all the blueprint, or as we saw in the previous demo, the first demo, I could just tell the AI to create a blueprint form. Now, the benefit in the UI designer is it has its built-in Torque extension that check the YAML for any Torque syntax error, like you can see here. But you can also download and install the extension to VS Code yourself and write the YAML outside of Torque, and then upload them to the source control and tell us to scan the source control directly. So it's flexible. You can either scan or you can build your own inside Torque. We can help you even with AI.
Thank you, Tomer. We had another question about what AI models we use in the platform.
Okay. So we use OpenAI 4.0 model for both the blueprint generation and the log insights. It's the first demo and the second demo. But for the VM activity detection, we went for a custom trained model using SVM, as I just said before, and a predefined, pre-trained data that we collected. And those are the main models as of right now. They can be changed in the future. We can choose other models for generation. We can go with cloud, but for now, we are using OpenAI and our own created model.
Great. We also had a question about AI insights for debugging. The question was whether Torque also corrects the errors based on those insights.
As of right now, Torque don't take any proactive measure to correct the code in the user assets. It's just notify on errors. It's also using the AI insight features to suggest you how to fix them, but we do have plans in the future to try and fix them for you and redeploy them for you, but only after the user reviews, of course. We hope we can do this seamlessly and to fix for you just on time the error. But as of right now, we just alerting them and giving you the access on how you wish to proceed. What's in the pipeline?
Great. We have one more question come through, and if anybody else has anything else, please feel free to submit them. But we had a question asking how what metrics Torque uses for the inactivity detection on VMs.
Okay, so we are taking CPU activities, we're taking in and out flows in the VM, basically everything that the cloud has to offer regarding metrics, we use it. Either in AWS or Azure, both of them have different metrics, but we use all the available metrics and feed them to the model. The credentials to get those metrics are special credentials for metrics that the user gave us, which hold the right permission in Azure or AWS or any other cloud, depending on the resources. So once we get the permission to scan the matrices, we scan them, feed them to the model, and we have a clear view whether the VM was active or not.
All right, that looks like to be everything we have for today. Thank you again, Tomer. Thank you to everyone for spending a little bit of time with us today. Special thank you to Corey on the background for making sure everything works correctly here. As I said earlier, please take a second to go to quali.com and visit Torque Playground, so where you can interact with all this functionality that you saw here today. And we will see you next time.